Hi, welcome to another video with another project. And guess what? It's another bowling machine.
Basically, every single year I try to make a automatic ball throwing machine that induces me to play along or practice along whenever I get time, uh, especially on home. Basically, it is my latest ball throwing machine, and uh, and it is extremely effective for indoor practices. But that machine I made around 2 years ago, but I noticed that I didn't upload the circuit explanation, and I think people deserve to know that how my circuit works and how I made that. So I thought I should definitely make an explanation video. But keep that in mind that I made that project while there was a pandemic and I was deeply in shortage of components, and that is the reason why my project build quality is so much poor. But let me assure you that it is the cheapest but most effective DIY project that is built by a pandemic caveman.
Now look at my breadboard and you can see that I am using two NE555 timer IC. If you look closely, then you can see that I am pressing two switches and the motor will be stopped for 5 seconds. Then it will complete its 2 to 3 rotations, then it will stop again. And that's how we save the power of batteries. Now let me tell you how the mechanism of this project work. So both are the spring of my project, and they are actually the thick wire that is being round shaped on the middle, and the end of the wires are attached to the base with a screw, and this ball grabbing structure is made with a plastic pins, and it is where my ball will rest. And you may find it very unusual that I am using a gear motor instead of a servo motor to hit the trigger, and the reason is here. First, I was about to install a servo motor on my project. Then the idea came into my mind that I really want to make it cheap and power saving. But servo motor takes around 5 volt, and a continuous PWM signal should be generated by the controller to keep the position of the servo. That's why it's not power saving. Now get back to the main business. There is two 555 timer IC, and they are in a monostable mode. So if you want to know what is monostable mode, here you can see the circuit below, and I have used BC547 and BC557 transistor. One is NPN and another one is PNP. Now how does the NE555 timer IC monostable mode works? The moment you press the switch 1, the output pin, which is in that case pin 3, will output a positive voltage. But after the fully discharged of the capacitor, which is connected to the pin 6, the output will be low. For the first IC, I am using a 60 volt 1000 microfarad capacitor. But here I don't wanna go with a deep conversation or discussion about the NPN or PNP transistor which is I'm using here, but let me give you a short description. So if I connect both the base pin with the output pin of a IC, then if the pin gets high, then the PNP transistor the load will be off, but the BC547, which is the NPN transistor, the load will be on. Now back to the main circuit. So connect the pin 8 to the VCC, and connect the collector of the NPN transistor to pin 1, and the base will be connected to the pin 3 of a 555 IC second one, and the PNP transistor base will be connected to the pin 3 of the first one, and that's it. That's how it will work. Yep. Now this is a more clear picture for you to explain it further more better. First, I will switch on the pin 2 of the second IC, and thus it will make the pin 3 as high, and and the base of the NPN transistor will be high also, and it will allow the flow of current through it, and thus it will turn on the first IC. The moment the first switch will be pressed, then the pin 3 of the first IC will be high also, and when the base of the PNP transistor is high, then it doesn't allow any flow of current, but the pin 3 will be on for 2 to 3 seconds, because my 1000 microfarad capacitor takes 2 to 3 seconds to fully discharge. On the other hand, my second IC's pin 3 remains high for 8 to 10 seconds because it got a 5000 microfarad capacitors. Now after 2 to 3 seconds, my pin 3 pin of the first IC will be low again, and as you know that the base of the PNP transistor is low, then it will allow the flow of a current and the motor will turn on. But after 8 to 10 seconds, my pin 3 of the second IC will be low. So as the base of the NPN transistor is low, so it will not allow any current flow, and as a result the first IC will be turned off, and as a result the gear motor will turn off as well. My project may look very cheap and awkward, but please believe me that it was 100% effective, and I enjoyed a lot while playing with it. And if you like this video and this project, then hit the subscribe button and follow me along. Take care and bye bye.